digitalization. One live was before the, I would say, COVID, and another one is a little bit after COVID. But first of all, really to thank you all and to thank the Slovenian colleagues and Lithuanian colleagues and really our office, Lina and Brigitta, that you are bringing together us all. First of all, politicians, decision makers, diplomats, and business community. For us, while we are negotiating and advancing some very particular European programs together with the Commission, it's so much important to see how they are being implemented in practice. And I think that our European agenda is ambitious and should be ambitious in terms of digitalization and future factories, because clearly one thing is that even before COVID, we all know that still European business, SMEs and large companies are pretty much lagging behind with their innovations in the digitalization. So and funding into digitalization. So that was even before COVID. We're lagging behind China, some other big countries. Now COVID probably came in and even showed us much more that we need much more energy, and the value added of the smart factories is going to be even much more on the agenda. So the COVID showed to us simple the weaknesses and the way to go, innovate and go digital. So I hope that you will really hear much more today from EITI colleagues, where, by the way, Lithuanian companies and organizations are also participating quite actively. We hope that you will be able to share your experiences from Slovenian and to hear some Lithuanian good examples of how our company is trying to go digital and innovate. Definitely, we have our national agendas, Lithuanian digitalization agenda, 4.0 industry agenda. But as you correctly mentioned, in the topic of the day is the future. So I hope that you will not only exchange the views, not only hear from, I see Mr. Klaus Betz about what the EIT Manufacturing is doing, what's the agenda, but also you will at the end might share some views and insights with us, while diplomats, while we are negotiating further here in Brussels for the better instrument. So simple, just good luck, and we're looking forward to hearing from you some feedback. So thank you again for being with us. Sorry for not being physically, but probably that brings much more people online as well and shows how digitalization is even important in these times much more. So thank you again and good luck.
Mr. Šimūnas, thank you very much for your introductory words and for some good messages. We are still within the time. It's only the beginning, but we are still within the time. I would really ask all the speakers to keep on time, please, because we don't want to be too long, you know. I would also ask all participants to send their questions by writing them in the system, and then after each block we will try to answer them and put them forward. Again, please keep on time, and I would like to introduce already our next speaker, coming from EIT Manufacturing, being its CEO, Dr. Klaus Betz. Klaus, do we hear each other?
Yes, you can see me?
We can see you now, yes.
And you hear me? Yeah.
And so we hear you, yes.
I will share the screen, just a moment. Oops. You see my screen? Hello? You see the screen?
Yes, we do.
Okay, then I can move on with my presentation. First of all, big thank you for the organizers to inviting me to hear a short presentation on EIT Manufacturing. You know, we are a new kid on the block under the umbrella of the European Institute of Innovation and Technologies. We are now operational by the 1st of January, so since a bit more than 6 months, we are around. And I'm happy to give you a brief introduction But let me first start with our topic. So really, manufacturing matters. I mean, manufacturing is still the core of the European economy and welfare. And manufacturing will be able to contribute a lot to the Green Deal we are aiming for in Europe under the new Commission's headline. And we have more than 2 million enterprises active in manufacturing in Europe, employing more than 30 million people. So here we have really a strong pace, and therefore it was really the time to set up a knowledge and innovation community dedicated to manufacturing by the European Institute of Innovation and Technology, because I think for Europe, manufacturing industry and production is one of the essential core topics for our economy. And what is our mission? So the global manufacturing innovation should be led by Europe. I think Europe has still a very strong position when it comes to automation and industry, to manufacturing as a whole. And to make it more concrete, our vision is we will not bring the production back to Europe. Yeah. So, but our vision is that wherever around the globe a new plant or factory is erected, the technology, also the digital technologies, the methodologies, that should be delivered from Europe, because here in the production technology, Europe has really a strong base. And how we want to achieve this? We want to bring together the manufacturing actors around Europe to integrate innovation and education for an entrepreneurial and sustainable Europe. This is our mission. And if you are familiar with the European Institute of Innovation and Technology, you know the base for all the knowledge and innovation communities for the KICs is the integration of the knowledge triangle. The triangle consists of innovation, business creation, and education, bringing them together. So we will connect people with skills with a strong focus on entrepreneurial education in the academic world. So really following the headline of the EIT, from the students to the entrepreneur, that the entrepreneur becomes really a role model for the younger generation that is worth to go for, to become independent, to establish their own businesses. Technologies with markets, from the lab to the market, bringing major technologies that have a huge potential faster to the market and accelerate the commercialization of such technologies. And connecting innovators with investors. So from the idea to the product, that we have a lot of people in Europe with great ideas, how we can support them financially, but also with mentorship, with coaching, that they can really bring their ideas forward and can establish new businesses. This is the integration of the knowledge triangle. And I think we have put together, when we applied for the call to set up the KIC EIT Manufacturing, a strong and unique partnership with more than half. There is 37%, but in between we have some new partners like Procter & Gamble, and they joined us. So we now above 50% of industry. We have roughly a third percentage of universities and 20% RDOs. And this is also the balance we want to keep in the future, to have a strong industry footprint within our partnership. And we cover the most important manufacturing domains like electronics, automotive, aerospace, robotics, consumer goods, medical equipment, process industries, and so forth. But nevertheless, our goal is to grow. There are still some gaps that we want to fill. So we want to grow over the next years within our partnership to become more than 100 partners. This is our goal for the next 2 years. And we have now in the so-called sugar year, in the first year, last year, and the beginning of this year, set up our organization as a non-profit organization according to French law, with a headquarter in France, in Paris, where I'm currently sitting here in our office in Paris. And we have 5 co-location centers established in the north of Spain, in the south of Sweden, in Göteborg, in Spain, it's in Bilbao, in Germany, in Darmstadt, in the north of Italy, in Milan, and in Vienna, in Austria. So our goal when we put a partnership together and defined a co-location center was really to build on the strengths of Europe and the northern part of Spain, the region around Paris, Austria, Germany, the northern part of Italy, the southern part of Sweden. These are, due to our opinion, the most important regions. And building on the strengths of Europe, we want to reach out to the whole 27 member states with our services and with our support for the European manufacturing industry. We have defined 4 flagships to focus our work really on where we can have the most impact. The first flagship is People and Robots for Sustainable Work. So how will the future of our workers in the shop floor look like? How will people work together with robots? I mean, we have a huge discussion in the public about self-driving cars. But far before we will have self-driving cars on our streets, we have self-driving vehicles in our plants and factories, moving around, having also people that are around having to deal with the self-driving logistics and self-driving transportation means that will be have in our factory. So this is a huge topic for us where we focus on. Additive manufacturing for full flexibility, whereas additive manufacturing is just one of the technologies that are now in a major state where we can really gain a lot of efficiency in our production line to go for personalized, individualized production. Our vision for the production of the future is that we step away from the rigid, predetermined production lines to very flexible production units where a production knows I can cut metal, I can do this, I can transport this. And together, all together, they are able to process a bill of materials. So this is our vision of the production of the future. Zero defect manufacturing and circular economy. I already mentioned the Green Deal, and manufacturing will be able to contribute a lot to the green Europe. So going for circular economy already from the product design, from the product engineering phase, that our products are really designed for recycling, for reuse, for using as less energy as possible. This is what we are aiming for in our flagship for zero defect manufacturing and circular economy. And finally, the digitalization, and this is what I would like to focus on a little bit more during my talk here. Digitalization to make the European manufacturing fit for the digital age. There is still a way to go. If you look at data spaces for manufacturing, where the data from user, from the productions, from all the suppliers that deliver prefabricated parts to the production, and also the supplier that deliver the production line equipment. If they all share the data, there is a huge potential to gain efficiency, to add new services based on this data around the product. But here, to establish such data ecosystems around products, I think there is still a lot to do, and therefore, digitalization changes everything, and especially in manufacturing. We are not at the end at Industry 4.0, if I may say. If we look at a history, it starts with a steam power, from manual to mechanical production. Then we had Industry 2.0 with the electricity within our plants and factories, the introduction of assembly lines, and so forth. Then the end of in the second half of the last century, the electronics, the automation that comes to our plants and factories and automate production processes. And now we are at Industry 4.0, and digitalization, as I said, still being defined. How data ecosystems will work, what digitalization means for a single product, for a whole product line. Yeah, I think there are still a lot to do, but and since the beginning, Europe shapes industrial revolutions, and Europe will shape Industry 4.0, and I'm convinced that Europe also will shape Industry 5.0. And if we look a little bit more in the future, and I was quite happy that Simonas in the beginning mentioned that a lot of companies in the manufacturing area lacking behind when it comes to innovation. So we still have to manage operational excellence, cost, quality, and time. This is what we have done, I think, quite successful in the past, and we have to do this in the future. But for the future, it is crucial for survival of our companies to really focus on the innovative dimension, innovation and transformation. This will be a huge challenge, especially for the SMEs. More than 90% of the more than 3 million companies we have around in the manufacturing arena in Europe are SMEs, are small and medium enterprises. So to support them, to help them, to make them fit for the digital age, and to help them to innovate. This is one of our tasks we as EIT Manufacturing are aiming for over the next year. And here is one example, a cross-kick project between EIT, led by EIT Manufacturing, together with EIT Digital and EIT Food, to digitalize. The goal is here to digitalize the full production line for food and nutrition production. As an desk production for teaching and learning factories, and also to use this, and this is one of our big things we want to aim for, is the cross-fertilization. So if we have implemented innovative approaches and have shown and proved their benefits they will bring to the production, we want to transfer this then to other industrial domains. So starting here with the food production together with EIT Food, maybe we can move good approaches here to textile or to other industry domains in manufacturing. So the cross-fertilization between the different domains is for us also a quite important goal. So with that, I am more or less at the end, and I hope I'm in time with my short introduction. So from our point of view, towards the future, to Industry 4.0, we will go from conventional industrial robotics and manual intensive labor to cognitive human-robot collaboration and smart mechatronics, and especially in the engineering phase, digital twin technologies that will allow us to design products that are fit into the circular economy demands. And for that, education is quite important. Therefore, we are setting up our master school, our PhD program, but also our guided learning platform to teach our workers on the shop floor, but not only the workers, also the management in the manufacturing domain has to be trained and educated. What does it mean to run a classical, traditional manufacturing business within the digital age? I think here we have to do education and training on all levels. So, thank you, and I am open for questions.
Thank you, Klaus, a lot. Very strategically. So let's see if we have some questions already now. Are you planning to stay for a while with us, or are you rushing somewhere?
I'm available here.
Okay, great. So you'll probably listen to some other speeches as well with some concrete cases, right?
Yeah.
Okay, but let's see if we have some questions for you.
I see that Mr. Kaldak has his hand up. I'll just unmute him. Maybe he has a question.
Okay, thank you, Bostjan. Yes, please.
Yes,
Just go
Christopher,
forward.
you're unmuted. Go ahead. Nothing.
We have here one question actually from Vania Ivanova, which is how do you build capacity in time of COVID training? You know, how do you organize it? Obviously, any idea on that, Klaus?
For us, the online trainings becomes more and more important, and also using augmented virtual reality, and especially our concept of teaching and learning factories. So bring the factory to the classroom with online tools so that the people have not to go to the factory to see a real factory, rather to have the possibility online to work in a real industrial environment. Yeah, this is the goal of our teaching and learning factories, to have here really high qualified online trainings for the people available.
Okay, thank you. We have some more questions, maybe. Another one.
Okay.
Again from Vania Ivanova. Can people on that basis start working?
You know, we are beginning with this concept. I hope they will be able to start working. You mean if the guided learning platform is already available, or if the people, if they are trained, could start working? That I got your question right.
Okay, some more questions.
I don't see any hands up.
Okay, Klaus, thanks a lot, really.
Again, yeah. No,
I hope you can stay for some minutes, maybe hearing some other presentations, and maybe you would have some questions for them, you know, because there will be some more concrete cases shown.
Yeah.
And thanks a lot, really, for joining us.
Let me also say a final word, what I forgot to mention during my presentation.
Yes.
Very important for us is really also the collaboration with all the colleagues in Brussels from DT RTD, from DT Connect, who work very close with them. I think they are investing in technologies that they get for a major state. And maybe there are really opportunities where we can take up these technologies and push it forward for commercialization.
Okay, yes,
Thank you.
Indeed. Thank you, Klaus. Thanks a lot.
Vanya has another question.
There is, yeah. There's another question here, yeah. But I think we should maybe move forward. Here's the question. Use guarantee is now reinforced and gives young people new opportunity to connect with you. Are you going to profit from the new EC effort? Well, I guess we will, huh?
Yeah, can you repeat it? I didn't get it, the question. Sorry.
Yeah, youth guarantee is now reinforced and gives young people the new opportunity to connect with you. Yeah. Are you going to profit from the new EC effort?
What is meant by the EC effort?
European Commission effort.
Okay. Yeah, of course. I mean, we are really looking forward for Horizon Europe and being embedded in the whole Horizon Europe. And as I said, working very close with DT RTD, with DT Connect, with DT Grow, with DT End, with other Directorate Generals. We are really looking forward on a close collaboration within Horizon Europe. Yeah.
Okay, thank you. Now let's move forward in order to stay within our timeline. So we are moving to next interesting block, which is Factories of the Future, case of Slovenia and Lithuania. And we have here three excellent, interesting speakers, two coming from Joseph Stefan Institute from Slovenia, Mr. Rudi Painter, Dr. Rudi Painter, and Professor Dr. Igor Kovac. And of course, we have here Director of Creativity and Innovation Center from Link Many Fabrikas from Lithuania, Dr. Adas Meškenas. So let's hear their presentations first, and after all three presentations, let's have some questions. So I would call first from Mr. Rudi Painter from Joseph Stefan Institute, and also he leads the Strategic Research and Innovation Platform on Factories of Future in Slovenia. Rudi, are you there?
Yes, I am. Do you see my presentation?
The connection, we need a connection.
Okay,
yes,
we can see you.
One moment, please.
Okay. Digital Master Bostjan is on work.
All right. Now you should be able to share the
Okay.
presentation. Right.
Just a moment.
Please keep in time, you know, on time. I mean, and within our timeline, Rudy. But please, the word is yours.
Yes. Okay. Thank you very much, Drashko. And thank you very much for organizing this event. And also my greetings to all the listeners today. And well, I am going first. Okay, first slide.
Just a moment.
Just a moment. Okay, just started presentation. Just a moment, because we have some technical problems. Okay. Well, I'm Rudy Painter, the Managing Director of Strategic Research Innovation Partnership Factories of the Future. So to see what is this, I have to analyze this through the Slovenia Smart Specialization Strategy, which is Slovenian Smart Strategy is we have first of all we have to make we have made a consensus what we want with holistic approach, and then we have aligned all the strategies, and also then we study all the smart specialization strategy impacts and priorities, and then we decide how we will finance it, and then we have to decide who will be the stakeholders. And so that is what the STRIP story is about. So STRIP is Strategic Research Innovation Partnership. And Slovenian Smart Specialization Strategy is an operational plan facilitating the shift to the high productivity economy through boosting innovation potential, fostering structural transformation and industrial diversification, and supporting growth of new and fast-growing companies. Slovene Smart Specialization Strategy has three main pillars: digital, circular, Industry 4.0. Around these pillars, we have established strategic research innovation partnerships, STRIPs, covering 9 priority domains. Priority industry value chains are knowledge supported by academia and politically supported through specialized calls, fostering innovation from TRL 3 to TRL 9. So this is a short description of the STRIP you can see on the slide, and I will not read this because it is on. So STRIPs are a kind of system intermediates and building new relations between triple helix members, spreading bottom-up initiatives, connecting academia and industry to achieve early awareness of new technologies and challenges of their exploitation and stimulate early government relations. This is our structure. We are actually STRIP Factory of the Future is a kind of innovation cluster powered by 4 beneficiaries, actually clusters: smart tools cluster, clusters of intelligent control systems, a cluster of advanced technologies, and cluster of smart factories. Structure is further divided to 8 vertical value chains, where there are mainly companies within the same market domain, and horizontal networks where 6 KATs, key enabling technologies, is providing knowledge to vertical value chains. There are also different common services available for all members. Traditionally, each domain is banded to one prevailing kit, but within this metric structure, each vertical has possibility to interact with many KATs, enhancing the domain value and knowledge. So this is the structure. You can see it's verticals and horizontals. And this structure is interconnected within all the actors of the Slovenian smart specialization and also internationally. Our membership is this way. We have 90 members and 83% are coming from industry. And our members are typically export-oriented companies with large affinity to research and development. Their global market orientation is in desperate need for incremental and disruptive innovation of their technologies, processes, and products. Innovations are enablers to remain competitive in high-demand niche markets. It's the same as colleagues from EIT have noticed in their presentation. And let me just connect with the Jožef Institute and SRIPS and Slovenian Smart Specialization. SRIPTOP is backed by technologies developed in Jožef Stefan Institute, which can cover the whole Tyrol range, giving confidence to industrial members and bringing broad technologies knowledge to the network. Jožef Stefan Institute is coordinating two largest SRIPs, which are providing key IT, key enabling technologies for all other SRIPs, and it is also very active in other SRIPs within different projects in their value chains. So what technologies we are supporting? There are, you can see the typical circle of Industry 4.0 technologies, and some of them are supported in other SRIPs. Well, we are adding KIT extensions. We are saying this so because we are adding nanotechnologies, plasma technologies, new materials, and photonics. So to go just briefly through our technologies, we have advanced robotics, and robotics is well developed in Slovenia with over 170 robots per 10,000 employees. A new established Yaskava production plant in Slovenia, their first in Europe, will be a catalyst to upgrade Slovenian robotics value chain to a strong hub and even further specialized clusters. So the key topics you can see on the slide, and I will not read it again. So with nanotechnologies, nanotechnologies are based of many advanced technologies which are widely used in different industries, new materials, optoelectronics, plasma, sensors, providing competitive advantage to early adopters. And these are key topics in our niche areas and our expertise. So then we are also using advanced technologies, photonics. We developed special laser sources to be used in medical devices for hospitals, of ophthalmology, beauty medicine, dental, and similar technologies to be used also for material processing in industry, like laser welding, PLD technologies, and additive manufacturing and sensors. So these are key topics in this direction. So plasma technologies enable innovative products characterized by ecological integrity and high added value. They are widely used in microelectronics, toolmaking, chemical and automotive industries. The current challenge is usage of plasma in medicine and agronomy. So here you can see the key topics which we are focusing with plasma technologies. Then we also have modern production technologies for materials, and they are backed by our basic research of several Jožef Stefan Institute departments for different materials technologies. We can offer the development within the whole TRL range. Main focus are different high-tech technologies used in several components in the electronic industry and antibacterial protection coatings in construction industry. Smart mechatronic tools. Today, tools are not static component in production process anymore. They are becoming a substantial part in connected cyber physical systems equipped with different sensors for obtaining information for quality supervision and predictive maintenance. Then also we have intelligent industrial automation management systems. The concept of the smart factory, which has been present in the world for quite some time, has entered a slightly more mature phase in recent years. From the general enthusiasm and the flood of modern terms, each interpreted in their own way, companies have actually begun to focus on the use of technologies and knowledge from which they expect concrete benefits. There is a great emphasis on general digitalization. That means the use of computer technology in all possible places, intensified automation and robotization of processes, and above all, increased integration of individual partial solutions in the common whole. So these are key topics we are working on, and we are very eagerly also introducing AI in all these processes.
I have to remind you on timing, Rudy. Hopefully you are getting to its end.
We're nearly at the end, Joshua, thank you. Then we have smart factories. The main aim of the smart factories value chain, led by the Chamber of Commerce and Industry, is engagement of Slovene industry for transition towards Industry 4.0. Technologies in high-tier levels, new business models are demonstrated to different industry sectors. Demo smart factory plant is used for learning and demonstration purpose. Yes, we have it. AI as a promising future technology is also extensively supported. So that are also main activities we are offering to our members, and you can see those, and I will not, one of the most important is technology transfer and normally internationalization. So we are mighty things, and thank you for your attention.
Thank you, Rudy. Very interesting. I must say that this strategic partnership in Slovenia out of 9 is probably the most active one, owing to Rudy's engagement and also Joseph Stefan Institute backup. So hopefully we can do some, some additional steps also internationally, and to get some partners to do something smart together, so to say. We have here next speaker already, Mr. Kovac. Igor, hi. How are you?
Ladies and gentlemen, online everybody. So I can't see you, but I hope you can see me, not live, but on a picture. So I would like to present our, at the moment, the biggest research program together with the Slovenian industry named GOSTOP. There are buildings, blocks, tools, and systems for the factories of the future. And this is a program on the field of factories of the future. This program has 4 main pillars: robotics, control technologies, photonics, and tooling. We have 19 participants, partners, and the coordinator have been Institute Joseph Stefan, and I was the coordinator of this project. So I would like to present now this program, about 10 million euros and financed from European Community, from Slovenia, and from the Slovene industry. If you can see here, it is just finished, and I am very glad that I can show you the results of this program. And these results are important to all participants, to all other companies who want to exchange products, experiences, to make new projects with our partners, to be in this time. So I would like to present only highlights from these 4 pillars. Here you have the names of the companies, but it's not only this company, it's only the communicator to the global community, and everywhere is also the partner, the name where you can get information, you can exchange information, and where can you also buy a product or to develop a new product and to integrate the product. And this is the main contribution of these highlights. Control techniques. This plugin is one thing led by company Collector. Data gateway. It's a almost finished product, and here was interesting that the company put additional own money to come faster to the market with this product. So they were not only to the level of TRL 5, 6, they hurry up with the development and they put additional money to the product to be at the market at the right time. Another company, Medtronic, a smart sensor design platform. They are successful by selling such things, and they have also a good reputation on this area in Slovenia and also abroad. Then IoT sensors for the company Spitzer. There was a coordinator based on visual voice technology. Then final quality is very important, zero defect manufacturing and so on. And here is a case study in the company Domel, together with Institute Jožef Stefan from Slovenia. Then another topic, multi-agent system for controlling industrial composed air systems, led by University in Ljubljana. So we are in control techniques really very strong at this area. Then tooling is very strong in Slovenia. They make for the automotive, airplane, and also to other industries. Here are topics: smart tools for pressure die casting and plastic injection molding industry, integrated interfaces together, Ticos and LTIC company, advanced hard coatings developed by the Institute Jožef Stefan together with the industry, naturally. Then IoT smart mist tool management developed from the company Collector and also marketed from this company. It is also a step ahead, this company on this area. Then software for predicting the lifetime on the die casting tools developed by the Hydria and Ticos and other companies. Again, there is not only one company. These were small projects in a big program which were connected to different companies, but here is only your partner who is responsible for talking about these topics. Robotics, as Rudy said, that this is a very important topic in Slovenia. We are very proud to have Yaskava in our country. So we have Yaskava, advanced control robot machining, then intelligent integrated drive system, adaptive robot cell, digital agents for automatic optimization. This is so kind of roof of the whole program led by the University in Ljubljana, Faculty of Mechanical Engineer, where digital twins in their agents and all the newest technologies which are important for all kinds of industries in Slovenia and abroad. Then modular software platform for optical inspection of products. And finally, photonics, a very promising area and field also in Slovenia. Here we have three very important companies. Eccentric laser system, scanning system for medical dermatological procedures, lead from Photona. Then sub-nanosecond MOPA laser system for removal of pigment laser and skin renovation, also lead by Photona. Laser transfer printing, prototype from the company LPKF and also other partners were involved. And Smart Yak system, very nice equipment, led by Institute Josef Stefan, and made together nice products with the Optotech company. So finally, some expected results. The interconnection of key enabling technologies recognized in Slovenia as breakthroughs. These were a main contribution to this program and supported by S4 Smart Specialization in Slovenia strategy, which were the main thing in this program. Then link between research institutions and industry in Slovenia. We established this link, and this was really very, very positive. And we established also new partnerships in research and commercial links. And we can offer now synergy between research and companies with competencies, capacities. And here is very, very important also investment from the state, especially in this area, tier 3 to 6. But we expect the continuity, which is needed, and it's a must, but missed. But I think it's not the problem in Slovenia, it's problem in Europe. When you stop with the European project, what's going? What is exit scenario? And this is also the problem here. What are experiences in the GoStop program? Benefits of a large program, because we could interlink research, institutions, industry by push-pull system, market, and to say to the companies, this will be a future area, and in such a way to cooperate with companies. Then achieving promising results. How? Involvement of the whole chain from basic research through development and experiments to a product, service, and technology. Basic research to the European and national support, and product services from the industrial support. This was very important in this program. Then excellent knowledge, talents, staff, and research equipment. So Slovenian industry was satisfied with this program, and we would like to have another and another and another such a program. And this is our wish, not only on a Slovenian level, it is also on a European level. Thank you very much for your intention, and all partners on this project will be very, very satisfied to cooperate with each partner in Europe, with small, large industries, with institutions, and so on. Thank you.
Thank you, Igor. This was a very concrete presentation, which is, always very good to see some concrete stuff. Thanks a lot. Let's move forward to last speaker in this block, Dr. Adaš Meškinaš, Director of Creativity Innovation Center, Link Menu Fabrikaš from Lithuania. So please, Adaš, are you there?
Yeah, hello everyone. Can you hear me?
Okay. Again, I have to remind you on timing. Please keep within, the timing, so we are, moving forward smoothly.
I'll try to do it in 10 minutes. Can you see my screen?
Yes, everything's okay.
Okay. So my name is Adaš, and I'm representing Creativity and Innovation Center Link Menu Fabrikas, which, if we do direct translation, Fabrikas means factory. But I'm going to tell you that we are not a typical factory. Here, I'm representing a department of the university, which was created as a unique ecosystem for co-development of, in general, technology, design, engineering, and manufacturing, where cross-disciplinary teams could turn idea into something like a first prototype, MVP. So in general, we try to connect what we have between the university, like studies, like research, and business, to give us some real case problems, and to cover the whole profile of our university. So this is engineering, management, and kind of like some kind of arts, like digital ones. So in other words, we're called as a makerspace or hackerspace. And as a typical makerspace or fabrication lab, we have some services or activities what we're doing. So first of all, this is prototyping, starting from 3D scanning to 3D printing, electronics, some material engineering, product design in general, and testing and consulting in general. As a not typical makerspace, we also have a department or labs of media, which we consider is very important to do the whole cycle of the project. So here we include virtual or augmented reality, some 3D modeling with animation, and some general media as audio, video, and photo making, for example, to present the project or the product. Another thing, we are also a platform for hackathons, for different workshops, events for networking, and some projects where we can connect industry, business, and researchers, and let's say students. We're also incubating some startups for which for what we help to develop the product itself and to promote it, and sometimes to sell it. Our projects are very different, starting from something like printing in nanoscale, or bringing I don't know, a huge sculpture to the desert of Burning Man. But today I'm going to talk about one of the examples what our team was working, and it's related to the crisis which was caused by the COVID pandemic. So I think this example is really great for today's topic. It's not something very big, but it shows maybe how the industry in general is transformed or is transforming. So when the pandemic hit Lithuania, we were facing great shortages of medical protection equipment due to the spike in demand. Face shields, which are rarely used in standard medical environments, besides surgeries and very select procedures. So those shields ended up being second in demand, only to the face masks, which have also been in short supply. So the problem was that the shields are only made by a limited number of manufacturers, and in Lithuanian case, all of them are overseas manufacturers, and those large manufacturers only ship units in batches based on orders from procurement offices of large medical institutions and local and state governments. And it was very difficult procedures, especially when the pandemic hit and everything was so fast and so on. So Linkmenų Fabrikas as a maker space, we joined the international maker forces who were already sharing some ideas on how to cope with the crisis. So we decided that we can make something, very simple, but what's very needed in a specific time. So we did some 3D scanning and started working on 3D models of the holders of face shields. It was decided to use different technologies, both 3D printing and laser cutting, due to possibility to involve as much different equipment and people what we had. As one of the main maker spaces in Lithuania, we are leading makers community in Lithuania. So here I'm talking about people with digital fabrication equipment in their garages or basements to some small and medium enterprises. So what we all done was quite impressive. Without having any previous experience of such situation, such crisis, also facing the global crisis in material delivery and logistics. We created a network which was able to produce and to distribute face shields to the front line of the medical equipment, medical staff facing the COVID. And so in 1.5 weeks, we produced more than 12,000 face masks. In 2 weeks, starting from the pandemic in Lithuania, the big factor is they adjusted their production lines and they started making shields with much higher effectiveness than we did, and the whole network of us did. For example, they were making the same amount of what we did in 1 week, they were doing in 1 day. But here what's important is that they adjusted their lines in 2 weeks. And we were able to produce shields and to bring them to hospitals and to distribute them in those first, the most, let's say, or psychologically the most important days. So this example, I wanted to illustrate that it's a crowd manufacturing by local makers, by local communities. In some cases is one of the ways for specialized design, for rapid prototyping and for quick delivery. When we have local production, when we have local materials here and so on. So I think this is one of the key advances of industry 4.0, or maybe even going a bit to 5.0. So what we actually also do to encourage this, to promote this, so we are, our recent projects are also...
Adash, I have to remind me on timing, sorry.
Yeah, it's 1 minute left.
Okay, great, thanks.
I'm done.
Sorry.
So what we're doing to encourage this, we are installing FAB Labs. We're expanding this network. So starting from 2017, we already have around 30 schools in, let's say, only in Vilnius. So this is 1/3 of the schools having FAB Labs with digital fabrication tools, starting from 3D printers, laser cutters, vinyl cutters, and electronics. And we have a new generation, I believe, new generation coming with some, knowledge and tools and abilities to do some kind of engineering, and those will be the people who will work in our future factories. So, okay, thank you very much.
Adash, great, thanks a lot. Also very interesting and very concrete. What I especially like, seeing good projects, that's something that, is balsam to my eyes, so to say. Okay, now we have this block finished. 3 excellent speakers, Rudy, Igor, and Adash. Do we have any questions from the audience? If somebody would like to speak up, but I would rather have the questions written in the system so we can, kind of organize them.
I don't see any hands raised.
Okay. I think, these presentations spoke for themselves. So they were really good. And as said already in the beginning, you will get presentations on our webpage after the event. So one who wants to go back to them and look more in detail, this will be possible, of course. So if we have no questions or we get any written later on, we would, of course, pose to the speakers. But we are still on time, so let's move them forward. So we have now next block of excellent speakers, interesting speakers, and excellent examples, so to say. This is, we have here, well, I will not name them all, but you have the program, you saw them, but let's go from the first one. This is Professor Dr. Niko Herakovic from University of Ljubljana, Faculty of Mechanical Engineering, and later on I introduce the others. So please, Professor Niko.
Okay, thank you very much for your introduction.
And again, the timing, I would ask you to keep in timing.
Yeah, I'll try.
Thanks a lot.
So I hope you can hear me and hope you can see the presentation. So I come from the University of Ljubljana, is actually also the research organization. And, the research is quite important to us, and especially for our laboratories, let's say it's very important that everything that we do in our research, we try to transfer this knowledge to the industry. So all this research that we have done in our laboratory that I will present also in this presentation was partly, not completely as a whole, but this was also transferred.
Professor Harakovic, we are losing you a little bit. Maybe you should speak closer to the mic, or...
Yeah, I try to...
Now this is better, this is better, yes.
I don't want to eat it, but it's close to my...
But the sound is better now.
Okay, thank you. We have more than 20 years experience in digital twins, and let's say in the last later years in smart factories. And our biggest project was the Yaskawa factory, new robot Yaskawa factory in Europe that we have planned from the scratch in the digital environment using digital twins. So all processes, production processes, logistic processes were done first in the digital environment, and then they started to build the factory. In the last few years, inside, let's say, in the frame of this GoStop project that was already mentioned, and also, let's say, in co-working with SRIP, we developed the new smart factory demo center and installed it in our laboratory. You see here the part of it. It's not huge in physically huge, but in the content it's quite big. First, we want to do research, and we do research, PhDs and so on. Then, of course, education is very important to us. Training of students during the study process, and also project work, of course, and education for industrial partners. We do this together with SRIP, with Mr. Rudy Painter, and also with our Chamber of Commerce. We will do this in the next period. We used, as you see here, different technologies. I just mentioned some of them. Simulation is very important. Digital twins are very important. Also, additive technologies we have introduced into this demo center, especially from this point of view that if some customer that we can present or demonstrate that some customer, if he wants to change the product, can change it, can send it to the printer, can print it, and the production line can take it into the production and recognize immediately. Of course, big data, I will mention it later. We try to avoid big data. How we did it, I will explain later on. Autonomous robots we haven't introduced yet because we don't have much space, but I hope in the future we will do it also. So I'll try to explain just briefly. 10 minutes is not much, just information what we did. Let's say concept was distributed manufacturing nodes, or let's say edge computing. Here we introduce different machines, or let's say not machines, robots, warehouses, machine vision systems, tool changes, and so on. Now we are continuing this process to introduce also location independent, let's say in different locations, different machines, let's say hydraulic presses or some other machines, and include them into this smart factory. So this was a very important concept that we started. Then we have, of course, global system control, and this global system control is done by digital twin. We don't use MES system or any other system. Everything is done by digital twin. So this is something new, because usually we use MES systems in the production. If we introduce digital twins, we actually don't need a MES system anymore, but we can combine, of course, this MES system. For data flow and for communication protocols, we tested many protocols. We decided for OPC UA protocol, and we use also RFID technology that gives the information back what is going on in the process and how the process is running. Because today we are talking about Industry 4.0, 5.0, we actually don't see a huge difference in those two, let's say, concepts, because we see all the time, and we think all the time that workers are very important. So we introduced into Smart Factory also workers. We introduced also, as I said previously, that customers can interfere into the project, into the process, production process, can change the production process also from the distant location. So we developed a new manual assembly station where, of course, with all technologies that are important for such manual station, adjustments and so on. So what is probably more important, we introduced also AR and VR technologies. We don't believe that AR and VR technologies are so important for manual assembly places, but we actually introduced them just to test them and to show how they could be used, because our focus is to make the production process and assembly manual assembly station in a way that that workers don't lose time, that they are very effective. That's why we developed a completely new software tool. It calls Last in Production Management tool, where with this software we can follow the production directly from the 3D product. When we make a 3D product in the 3D modeler, we take this information and everything is done then automatically. All instructions, product structures, images, 3D models, and so on, if they are necessary. So that you can see here on the monitor, for example, how this is done. So the worker can use it very effectively. We also implemented this technology into industry, and it was very, very effective. We started when we started the concept of new demo center. Of course, we studied different models, architectural models of Smart Factory, RAMI, you know. But then we saw that we have to do something. We had to do something. So we updated this model further on in 2D, two-dimensional model. Is this? It's called Last in Smart Factory or LASFA model, because we wanted to make a model where we can put everything, every detail in this model, so that if you plan new Smart Factory, you can really just follow the model, and from different levels, from very, very basic level of the product to the control level, where we have digital agents, digital twins, and as I said, as we use edge computing concept, we have a lot of digital agents, a lot of small digital twins locally that they solve the problems if they appear in very, very small amounts. So that's why in such a way we avoid big data. We have just smart data, and it's very, very suitable for for small and medium-sized enterprises. This was the goal, how to do it. As I already mentioned, digital twin, a cyber-physical system, is the basis of this Smart Factory. And this is also the basis of our research. We do a lot of things with that. We combine then these digital twins with artificial intelligence. And in such a way, we make digital agents. And these digital agents, we can have a lot of digital agents. And in our demonstration center, we have quite a few. And they are interconnected to each other. They talk to each other. Also, the objects in the production talk to each other, and they try to solve the problems among themselves. And of course, they communicate also with the global digital agent and also with the digital twin. In such a way, the process.
Professor, I have to remind you on timing, please.
Yes, I'm already finished.
Great, thank you.
In such a way, the process is completely autonomous. We don't know what is going on in the process. It adapts itself and tries to be as much as possible efficient. That's why we have this feedback system from the real system, from sensors, directly to the cloud. From cloud, we take it to digital twin, digital agents, and they decide on the information in real time what has to be changed, and change the system by themselves. We also made everything in 3D, so virtual reality is possible. We can go into this virtual world and go and walk through the process and see what is going on in the process. So as I mentioned, this was done through the GOSTOP program and also in the cooperation with the SRIP leadership and also some SRIP top members. So here are contacts of myself. Thank you very much. If you have questions, I will answer them.
Thanks a lot, Professor Karakovic. Also interesting case. We heard something about it from Rudy before, but you know, this is much more concrete. Okay, let's move forward now.
There's also a question below the chat.
Okay, but I mean, we said we have questions at the end of the block. So maybe, well,
okay.
There's no question in written. There's somebody rose his hand, I understood. But let's have the questions at the end of this block, like we said, okay? Is that okay? All right, let's move forward. We have now Dr. Žiga Gosar from LVS company, and they will present digital twin use case. And there is also Professor Domen Mongus, who participated there from University of Maribor, Faculty of Electrical Engineering and Computer Science. But presentation will be done by Gosar. Žiga, please. But please keep on timing. Really, we are already running out a little bit of it.
No problem.
Okay, great. Thank you.
Hi, hello. So Žiga Gosar from company Ilves. As you know, Ilves is a manufacturing company. We are a cable harness production. We have plastic injection molding, and we have also high vacuum utilization. So this means a lot of labor work. And we are collaborating with the University of Maribor, with Faculty for Electrical Engineering and Computer Science. Our goal was to make also the digital twin, but as you can see, there is a big difference because, as Professor Karakovic was saying, he's making digital twin on the processes that are, let's say, made by machines, but we are working in a factory which is, let's say, labor intensive. So for this reason, we made a lot of analysis. We saw that in companies, we have a lot of software systems, but they are not properly connected to each other. We have a lot of data, but they are also not connected to each other and, let's say, properly analyzed. So with traditional and this static way of thinking, we are currently making some planning and production processes. And with this, we can be, let's say, good in overall equipment efficiency for the machines, but the processes are, let's say, not so good and they are not so efficient. So based on this, with collaboration with Faculty for Electrical Engineering and Computer, we decided that the future to this step is digital twin, but not just digital twin. The future is flexible planning of planning system for humans and for the equipment. And based on this, that we are making analysis, we decided to also to go into different pillars, and we decided to analyze the whole logistic, to analyze the whole purchase, let's say material, purchasing of material, how this is going, to see how the production is going. So over there we used lean methods like Poke-Yoke. We are making value stream mapping, activity-based costs like ABC, and of course total preventive maintenance, so that we have everything. We have a lot of data and all the data, let's say, properly stored. And of course, with this static way of thinking, the goal of in overall equipment efficiency is always, let's say, 83. It's about 83%. And as you can see from the graph that is shown, we are constantly in production. We are constantly moving in this yellow region. And based on this digital twin and with our collaboration, we want to make this flexible planning system. And this means that we want to come from yellow region into a green region. And this green region means that we will constantly be moving in optimal costs of production. Because in production, in production companies, we are constantly talking about costs, and these costs are, let's say, a huge issue in the process. On the top right, you can see the analysis that we made, how our machines are efficient, what are the paths, and how frequently we are transporting the material from machine to the storage room and to the logistic where we put the material onto the trucks and ship it to our customer. So with this digital twin, where all the data will be properly connected and analyzed, the goal is to do this flexible planning system for human and equipment. Now, currently, everything is made just for equipment, but humans, let's say the manual force is not properly scheduled, and this is what we are working on now. And with this system, we will give delivery dates instantly, and we will have also better efficiency and also improvement. With this, we will carefully plan the production system and enhance transparency. So, yeah, this is it. And we will improve capacity utilization. We will reduce cost of inventory and, of course, cost of production process. With this, we'll create multiple and synchronized plans for processes, because we know that not all processes are made on machines. They are made on machines, and then the assembly is handmade on in different places. And with this system, we will also support more complex configurations, and we will have, let's say, a bigger flexibility. And with this in mind, we made, let's say, a small two to three processes. We put them inside, and then we are changing we are testing the background. And with this, we saw that with proper algorithms, we can make a digital twin, and we can come to the optimal cost of production. And based on this, we are now trying to make this proper flexible planning system. And as you can see from this on top, you can see our layout of production, and you can see that now the machines are green. So this means that they are not so occupied, and they have a lot more space, or let's say free capacity. So this is it. And with this optimal cost and optimal planning system, we can then work better with lower costs and with higher flexibility. Thank you.
Žiga, thanks a lot. Okay, let's move forward. We have here Podkrižnik company. This is strong SME from Slovenia, very innovative, very successful. And we have here Dr. Simon Kulovec from this company to present us their case. So please again keep the timing. Yeah, and the floor is yours, Simon.
I'm just looking for this sharing.
Mm-hmm. Can you help here?
Yes, it's in the center of the screen at the bottom, like Skype. So after the mic, the camera, there's a box with an arrow.
Yeah, I have that, but I still didn't.
So yeah, there
it says share content, yeah.
Yeah, that's right.
Okay.
Simon, now we see it.
Yeah, we see it.
Okay, thanks.
But please keep on time.
Yeah. Okay. Thanks for your presentation. Hello to all from my side and side of company Podkrižnik. Our company have two locations and two main parts of production and development. So we have one facilities in Slovenia where we have headquarters with research and development center. Here we have manufacturing of components for drive systems and the whole drive system modules with also plastic technology and products. And then we have another manufacturing in Germany, nearby Frankfurt, where we have manufacturing of high precision hydraulic components, valves, modules, and also other different gear parts and models. The third division is our marine program, where we also have here in Slovenia development and production of electric motors for boats. Just a short maybe picture of the locations. Our company was established more than 30 years ago, and now just a second. Okay, and now we have altogether employees about 300, and also this our new brand, Podkrižnik Group, was established this year, where we, how to say, have these three different fields.
Okay.
So, we are a system supplier, and we have all needed certificates for different industries, and we then provide some business partner, customer, different activities from research to the final manufacturing and assembly of the products. Of course, really important in our company is also our lab for measurements, for different research activities, because we produce very high precision components, and this is really important that we know at the end what we produce. Maybe just a few our main parts. I believe that you know someone. Now I just want to make you a short presentation of this robotic fields in our company. So we are for several years we are working on development of high gear ratio gearboxes for robotics and maybe some other high precision applications. We also cooperate we also was cooperating this program GoStop, which presented by Mr. Rudy, Igor, especially Igor. So here is the planocentric gearbox. This is our own patented solution for robotic industry, for robotic joints. This is intelligent product with sensoric and have this accuracy backlashes more or less than 1 arc minute. For example, this in picture is one with nominal torques 120, but we have also we build different different products in this field. So this is our platform range. If we see, this is our range. SGU plus is our name of the field acronym. Max diameter up to 190, gear ratios till 160, and torques till 500 Newton meters. Design concepts which we already have. It's from gear ratio 48 to 120. These procedures, of course, because we have really low backlashes, because of that we also need very good measurements and equipment. So we also make all these different tests, temperature test, noise, acceleration, efficiency, backlash, different slip torques and kinematic measurements. Our last project, which was not started, or we know what we want, but we are now in also we just pick up the team and how to say specify the project. This is the new. This is the Lupo. This is the name, low-cost user programmable and operatable robot. The main goal of this project is low-cost robot arm, which is easy operate by everybody, every lay person who is not an expert, and it's especially important that this robot we want to be in the range of 10,000, somewhere in 10,000 euros of course per robot, and could be like a help in everyday tasks for, I don't know, older people, some other people who some boundaries with motion and so on. In household, maybe if somebody needed. This is maybe just a quick presentation of partners. We have also partners from Austria and from Germany, because also we want to put this robot in field of surgical operation and so on. Main specifications: 6 or 7 degrees of freedom, customized gripper system, payload we have up to 1.5 kilos, reach to 1 meter, and of course this is not so much in industrial field, but more than non-industrial robot. So I believe that this is all from my side. Thank you very much.
Thanks a lot. Thanks a lot. We have one question for you, but let's finish first the whole block.
Okay.
And the next is Dr. Aleš Hančić from TECO Slovenian Tool and Die Development Center. Aleš, are you there?
Yeah, I'm here.
Okay, great.
Hello.
Again, keep on timing, please.
Sure.
I know I'm boring with this, but still, you know.
I know.
Great to have you here, and please, the floor is yours.
Thank you very much. Okay.
Yeah, here it is. We can see it.
Okay. Thank you very much. So I'm Aleš Hančić. I'm coming from the TECO Slovenian Tool and Die Development Center. We are a small research center and a company for production, development, and prototyping. Actually, our main course, what we do is basically helping companies design new optimized products and troubleshoot their problems, so everything in their production, in their products is running perfect and without any problems. We are actually not only day-to-day solver, but we cooperate with all major players in the region, not only in Slovenia, but also outside in Slovenia as a long-term strategic partners, helping them basically develop new products, new tools, new molds, and new technologies. We have 4 main pillars of our activities. It's engineering services, so helping, as I said, in the production, in the development, in the optimization of products, into helping their production process to be as optimized as possible. We are also working as a research organization. We help, we usually work here with all the companies, helping them manage and apply for R&D projects, getting EU funds, getting Slovenian national funds, and the research, new materials, new procedures, new processes, and everything that helps them into becoming a state-of-the-art company. We are also a training facility. We have many specialized trainings. We also offer job qualifications. We work with universities, high schools and similar, and we can help the production workers, the developers, the engineers getting new knowledge, and we transfer knowledge to those companies. We are very specialized into the transferring knowledge on the Industry 4.0, but also into the renewable energies, new materials, biomaterials, and similar. And at the end, we also work as an industrial association of the Slovenian tool makers and tool users, and we are one of the largest associations in Slovenia. We are basically, our engineering services vary from the development of the design of the products, of the development of the whole assemblies, optimization of the products with virtual analysis, FAM analysis, simulation of the processes, scanning, measurement, and of course tooling and prototyping, varying from the prototyping in the molds from the 3D printing, metal, and also plastic 3D printing, and everything needed to have the prototypes and running production in no time. Of course, as I said, we are very strong also on the research department. We have dedicated research facilities. We are very strong in processing technologies, new materials, we are one of the first in Slovenia to research the biomaterials, biodegradable materials, biocomposites, natural fibers, reinforcements, and similar, and also everything done needed for the Industry 4.0. We are one of the leaders in this area, Slovenia, and of course, anything with the green technologies, life cycles, and environment protection. We have our own equipment, our own labs, where we can, of course, test and produce the products that we develop in our facilities. We have per year we do more than 30 specialized trainings for all the trainings for all the people that they needed, from the shop workers, machine operators, to the designers, to the decision makers into the companies. I would present here today our own project that we want to develop, and we also will go to the market with it. It's acoustic monitoring of injection molding process. We call it Moldier. We basically patented the acoustic sensors to be used not only as they were previously used, but we tested signal detection and what we can get out of the mold with listening to it. So to record the basically acoustic emissions, and then we can see if we can with analysis detect what is happening inside of the mold. So basically what we want to do it is have a real-time production monitoring, real-time error detection, whether it's the, let's say, injection molded parts is faulty, or the tool is broken, or anything that happens with that, to ensure that we have predictive maintenance, so to predict in the future what will happen to the molds, that we can shut down the production if anything is going wrong, and of course to perform all kind of statistical analysis of the production of the process, and to communicate with all other sensors, actuators, units, and of course to put everything into the cloud and operate from the distance from wherever you can. It's a little bit different. There are some systems already on the market that do this, but we want to simplify this as possible. We want to have easy assembly. We want to have minimal modifications on the tool. We want to have low price, and of course we want to provide at least equal or greater functionality than any kind of competitors that's already on the market. Our device is always, it's not only a system for the mold, but it's a part of larger systems. Basically controls all other peripherals that are in the shop floor, so the robotics, the automatization, the monitoring of the whole process, so the MES systems, and you can basically monitoring everything which is happening in the floor of the production. So of course, as I said, there's a lot of competition already. They work on different principles, but mainly if you want to work effectively, current companies that are dealing with the production and monitoring the production of the plastic parts usually works on the pressure principle. So they measure the inside pressure of the mold. And while this is quite accurate, it has very downside. You have to change the mold. You cannot do it in the old molds, and it's very costly. The sensorics is very costly. The preparing of the mold is very costly. It's very time consuming, and it's only done for one mold at the time. So our system that we are going on the market is can do all this that we want to do it, but it doesn't have the high price. So if you talk about the comparison to other systems, they start around 10,000 euros to 15,000 euros with a lot of work being done on the mold. We start with the price of let's say 1,000 euro to 2,000 euros, and the price could be even lower if there is a set of multiple monitoring system purchase for, let's say, for the whole factory, for the whole molds that they have in their factory. So the conclusion of our project, that was also partly financed by the GOSTOP project, but it's also huge involvement also of our own knowledge, is at this time there is no ideal solutions on the market. We need cheaper solutions, and we must basically fill the gap that it's currently in the market. The final goal is to make molds not only I would say cavities made of steel, but smart systems that are connected to the machines, that are connected to the industrial internet, that are connected to the cloud, and I would say self-repairing and self-analyzing tools, so-called smart molds. So this is the first prototype done. This is around half a year ago. We are now making smaller and smaller prototypes. And the basic, as you can see, the basic advantage of this kind of system is that you don't need any corrections into the mold. You don't need to drill any holes. You just attach this box to the mold with magnets, and it starts to measure and starts to take data with their acoustic sensors. So basically very easy installment, and you get huge data. And of course, equipped with artificial intelligence, you can basically predict and operate the whole production of your plant. So thank you very much. If you have any kind of questions, I'm really glad to answer you.
Thank you, Aleš. So cheap and efficient solution, one would say, right?
Yeah.
And you go for breakthrough. Okay, great to hear that. Yeah. And I think that was interesting for everyone. And now we go to the last speaker from this block. It's Mr. Miloš Petković from Kalmia company. This is SME from Slovenia, and we will hear something about unlocking business potential with trusted data.
Yes,
okay,
correct.
Yeah, and again, timing please, and let's go.
Sure. So
thanks.
Hopefully you see my screen.
Yeah, we see the screen. Everything's okay.
Right. Hello to everyone. My name is Miloš Petković, and I'm leading the authorial department. So we are a technological company and have developed a platform to help manufacturers really build strong partnership on the basis of trusted data. So we believe that because the data is present in all of the companies, we believe that trusted data is really something that is able to help manufacturers become a smart factory. But company, the concept of a smart factory is kind of similar for us to a smartphone. So the smartphone itself is not smart at the beginning. what it makes it smart is applications and connected data and how it is being transferred to the user. And when we think of smart factories, we think of data and how data can help an average manufacturer use it for their advantage in order to really to create smart factory. But a starting point for an average manufacturer is not that easy. So they have a good product, they have all sorts of systems, but when a client, for example, wants to have find out more about product history, about other informations about the production, they have a challenge because the data is not connected, and it's within the multiple systems and in various formats, and sharing the data with the customer is really a pain. It's really a challenge. So instead of an average company and the sales team to be really selling and to be servicing the customer, they are spending time for sourcing and sorting the data and then sharing the data to the customer. When proving compliance because of this disorder is really difficult, and without a system is sometimes impossible. And data integrity in a smart factory is very, very important. So what we do with Autrail, we bring a data management system that not only brings the savings and the efficiency, but it really brings to the company that they are able to react more quickly to the customer demands. They are able to avoid penalties, to ensure regulatory compliance, and to fight counterfeit, and ultimately to really bring transparency and trust in the business partnership. And a smart factory without a system which is not able to provide a complete picture over its standard operating procedure is not really that smart. So it's like phones we had like 10 plus years ago. So what we do with Autrail, we aggregate and organize data and documentation. We add metadata for context and seal it with blockchain technology to protect it from changes. And this is very important when companies need to provide some sort of proof of their production conditions at a time when the product is produced, or to provide a proof that their measurement and the quality tests have not been changed. So a company selects what data the customer will see, or what data they will be able to share. And today the companies must provide and prove enhanced product safety and data transparency. So opening up your data to the customers is becoming fundamental. But to be more practical, we have a German customer, a bearing solution producer. They are producing for aerospace and robotic industry, and they are digitally advanced. So we can say that, but still they are not able to prove authenticity of their manufactured products, and they are manually extracting data from their systems and then share them with the customer. So, for example, it's a story that their client has phoned them and asked them if they perhaps changed the grease in the bearing itself because it smelled differently. And then 4 people searched for documentation and data throughout the company for 1 day in order to prove that nothing has been changed. So 4 people and 1 day. So who measures that cost? So what we provided a system, a automated way that provides a complete picture of the relation between the customer and the company. So when they are able, so and it's one that having internally for the company to be able to see at one location what is happening and what are the important informations about the, let's say, the order, and the customer which is able to see what is the status of the order, to see the data from the production, to see the important documentations like certificates, like specifications, instructions of use, and so on. They to be able to reach another level and to link the physical world with the digitized. They have even printed out the QR codes to their bearing solutions, so that they are able even to track what is happening at the customer side, and the customer is able to confirm, for example, the delivery, and they are able to track what's happening with the customer. So, and pointing that, so we don't touch any data and documentation that is safely stored in the customer's systems. What we do, we connect it, we aggregate, we protect it, and then offer it in an organized way to the customer. So, and this is how we see how we can help, how data can help companies, an average manufacturer, to become a smart factory and really to use data in their advantage. Yeah, that's it. Thank you very much. So,
okay, great. Time, and we're still on time. And of course, we have now the questions for the whole block. In the meantime, we got a question for Podkrižnik, for Podkrižnik company, regarding how their production is green, so to say. Maybe a short answer on that one. Do we still have here Simon?
Do you hear me?
Yes.
How our production is green?
Yes, that sort of thing, right?
That sort of thing.
Is hydrogen in particular green on your agenda? That's the question exactly.
Which hydrogen?
I don't know.
Yeah,
I just read the question. Is hydrogen in particular green on your agenda? Like e.g. shipping? Okay.
Question, I'm sorry.
Okay. Okay. If you get additional clarification, we'll come back to you.
Please, yeah.
Bostjan, do we have any hands up?
I don't see any, no.
Okay, if not, then I suggest maybe, still keeping in time to go on our last two presentations, and then probably we'll have some questions. We have, let's say, like Germans would say, Zucker kommt zuletzt. We have here two presentations. And first of all, we have here our colleague from European Commission, from DG Connect, Mr. Matthias Kuon. Matthias, are you here?
Yes, I'm here. Can you hear me? And can
yes,
you
we
see
hear
my
you.
Presentation?
Yes.
Perfect.
Yes, we see it, and I would also ask you to keep the timing.
Yes,
that we have some question later on. Obviously, we didn't have many questions so far, but I think the presentations were so clear that that was quite obvious one, and of course, people can see them later on our website.
Yes.
But Matthias, please go ahead.
I hope that my presentation is also that clear, because now from these concrete examples, I come more to the big picture, what the European Commission is thinking and supporting here in this field, especially with the new Digital Europe program. That is a program that is not on research and development, it's on capacity building. So it's more closer to the market. And if I now come to the topic smart factories, or how I would translate it AI in manufacturing, then we have heard already a lot about data, digital twins, and what is done. So I don't have to explain you what AI can do in this field. There are many examples on predictive maintenance, but we see also things that are not directly related to the shop floor, like possibilities to enhance the product design, and also lots of topic around the supply chain. So we see not only the factory as itself, but the complete manufacturing process here. As with many other digital developments, we see an barrier of AI adoption, especially for SMEs, and that's why we address with our measures specific also the SME sector. And if I come now to our Commissioner, Thierry Breton, he wants that European businesses, make use of data and make value of data, and therefore develop this kind of AI AI applications that make these data business potential. And therefore, in February, the European Strategy for Data was published, which had two parts. One was especially on AI, and the other was on data, because our commissioner sees data as the basis of this all, and we have also heard this in the examples this morning. And when we now look at the different actions in the AI sector, we have here 6 key actions. One is the coordination with member states. Then the second one is strengthening research and innovation. Here we have already done a lot with Horizon 2020, and also the successor program Horizon Europe will address this. But we also want to improve skills and have here coordinated action with member states on the talent. And the fourth topic I want to quickly highlight, this is a special program dedicated to the SMEs. This is our Digital Innovation Hubs initiative that we have started in the Horizon 2020 program with so-called innovation experiments, and in the new Digital Europe program, this will be a more continuous endeavor where we will establish European digital innovation hubs all over Europe. In every region there should be a digital innovation hub, and this digital innovation hub shall react on the demands in the region. These can be from different sectors. This can be from the manufacturing side. This can be from agriculture. This can be from the textiles industry, depending on what's needed in the region. The hubs will provide competencies that these business in their region need. And then we have, of course, also bigger programs in PPPs, like the PPP on AI, data and robotics, where manufacturing also plays an important role. And the other PPP that's important here, the Made in Europe program, you will hear from Jaco after my presentation. So why do we think we can have a strong role here in this? This is because other as in the B2C sector, here in the B2B sector, we have a strong European basis in the manufacturing industry in different areas that are mentioned here. And it's also a very export-oriented business. And here we have to have a lot of data that is already available, but often not used, and that can be better transformed at all sectors of the economy with the use of AI. And the advantage here in the manufacturing is that you're not only talking about personal data, but also non-personal data, where sometimes it's easier to exchange this, but still we see lots of problems there, even if the number of industrial data is tremendously high. We see obstacles like liability topics, licensing topics, but also lots of companies can really estimate the value of the data, and therefore they are not starting to exchange this data with others because they fear of losing value that they can't really describe. So here we have to do a lot in our European strategy for data to encourage such a data sharing, because we think this data sharing helps in new business models that will use this data for personalized product offerings and tools. And therefore we have developed this strategy with 4 different pillars. One is on the legal framework. One is then on the enablers. As enablers, we see, for example, cloud infrastructures. Here we want to have European cloud infrastructures that build upon existing cloud providers, federate them, and make them competitive to the big US and Chinese cloud providers. Under this topic, you have initiatives like the Gaia-X initiative from Germany. The 3rd pillar is on competencies. Here we have this digital skills program I mentioned that wants to develop skills in general. And here we also have this digital innovation hubs support that wants to help especially SMEs in developing their business models further on. And we then have as the 4th pillar this rollout of common European data spaces, which I will now explain a little bit. These common European data spaces we intend to develop in different sectors. They are shown here. It's from health, agriculture, finance, and mobility. And one of these data spaces will be on industrial and manufacturing. And here the strategy says that it's important to have these large pools of data in these sectors, and it can be different pools depending on the specific value chains. So the stakeholders in the value chain have to decide with whom they want to share these pools of data. And we need, of course, the tools to make these exchange trustworthy, and to give the possibility to really have the control, the governance of your data. So the focus is on sharing, pooling, and using, and also to really deploy these data spaces. As I said, this Digital Euro program is not a research and development. This Digital Euro program wants to acquire existing technologies and to build up capacities with these already developed technologies so that it can be really used by the companies in the different sectors that I mentioned. And now I want to go to the next slide. One example where we see that this data exchange across company is already happening is the Smart Connected Supplier Network that started in the Netherlands around the chip manufacturing value chain. And here especially the smaller third and second and third tier suppliers identified that this data exchange brings advantages to them in better information about what's happening along the value chain, in better communication, how their availability and their process status is. And here we see this as one example on which we can maybe build on when we want to establish such common European data spaces in the manufacturing area. Here you see that it's an open initiative with open standards, and it has already a lot of stakeholders gathered together under this umbrella of this smart connected supplier network. This is maybe, as I said, the starting point. But we also had, for example, on the 6th of May, a webinar with I think 200 stakeholders from the manufacturing domain, and with them we discussed where we should put the focus on, and the preference that was mentioned here is we should put the focus especially on this data sharing and not so much on the data reuse. You can see the numbers here. And as use cases, there was mentioned on the one hand this maintenance use case. I mentioned predictive maintenance already in the beginning, and also this supply chain planning data, where I gave this example from the Netherlands. And when we are now thinking about the governance model, how such common data space should be managed, governed, here the preference was that 42% preferred a distributed implementation instead of a centralized one. So here you see how we currently develop our thinking around this data space topic that is mentioned in the strategy. And with this picture, I want to show you what we see as common elements that will be available for all the data spaces, and what we see then as sector-specific part in this manufacturing data space, and how this will be combined with other initiatives in this Digital Euro program. Another part of the Digital Euro program is, for example, the development of the European AI on-demand platform. And another topic is also this AI testing and experimentation facilities that I will explain in a few seconds, because we think it's a matrix with different aspects. On the one hand, you have to see how the data is shared, and we think that it's important that you come from an inside the factory data usage to a first step company-wide data usage, but our goal is to have this cross-company data sharing models. So this we want to support with this data spaces, and you have to come, this is the other part of the matrix, from the basic analytics to the advanced analytics. And one thing to support this is these AI test and experimentation facilities program, where we want to establish such facilities in different areas. Here we also have topics like agri-food, smart hospitals and healthcare, smart mobility and smart cities, and as the fourth topic, also manufacturing. And on this slide, fifth topic is missing. This is the hardware part, where we want to address especially the edge computing that was also mentioned in one of the presentations. And if I go here now to what we want to do in this AI test and experimentation facility on manufacturing, here we want to have real production line maybe, or also maybe a place where you can develop AI applications for supply chain management. So these test and experimentation facilities will give AI developers the possibility to test their tools, their software, to see if it's interoperable with other offerings in this value chain, and also maybe to certify their tools on standard compliance and such things. So these AI test and experimentation facilities offer especially the small and medium-sized enterprises an opportunity to really validate and evaluate their products before they go to the market, and we see this as an important support measure. So if I see at my watch, I think I was in time with 15 minutes, and well, was a lot of stuff, but I'm open for questions, of course.
Yes, Matthias, thank you. That was perfect timing. Indeed, we have some questions for you. And
okay.
The first one from Julia Mihail from Romania. It's our colleague from Romanian office. Similar office like our Slovenian office. So the question is, will data spaces be developed in conjunction with EOSC, or are there two totally different approaches regarding data?
EOSC, the European Open Science Cloud. Yes, there is a conjunction, but it's not the same. So as I said, the Digital Euro program is for close to the market developments. So the data spaces will be for real world use cases and not so much for research and development for science. So it's not the same infrastructure, but of course the colleagues from the European Open Science Cloud are in close contact with us, and we see here more overlaps with the federated data, with the federated cloud infrastructure than with the data spaces, but there is an interlink, of course. Yes.
Okay. There's another one, and with regards to Digital Europe programs and associated manufacturing data spaces, how does the European Commission view question of third country access? Is access foreseen, and if so, will they be treated different to member states and restrictions to be placed on them?
Well, first of all, these manufacturing data spaces, or the data spaces, mainly want to address the companies within Europe, and here we have the participants in this Digital Euro program, where we have the member states and also hopefully some associated countries like maybe Norway or Switzerland, but this is not confirmed now.
This question is put from the UK.
Okay, yes.
Scotland.
So, yes. With the UK, we currently don't have an agreement. So here it would this would depend if you have also parts of your company within the participating member states, for example. We haven't defined this in general, how the access rules will be, because this should be defined by the industry stakeholders. But our goal is to mainly address companies from European member states.
Okay, thank you. Well, we don't have any questions. Matthias, that was very informative. Thanks a lot, really.
Okay.
Are you leaving us, or are you staying for the last presentation?
I will stay for the last presentation.
Oh, that's great. Thanks a lot. Okay, let's move to last presentation. So, Made in Europe, Mr. Jelko Pazin, European Factories of the Future Research Association, so-called EFRA. Well, being member of the board of Vanguard Initiative, had some, let's say, some contacts with EFRA and Made in Europe recently, in order that we would like to have some strategic cooperation. So Made in Europe, it's obviously very I would say active association and very interesting one, and really fitting in very well in our conference today. So Željko, are you there?
I'm here.
Okay,
Do you
great.
hear me? Okay.
So the floor is yours. I hope you can also fit in your timing, so we can really have the conference, the whole meeting in fitting in the time frame. Thanks.
Thank you
The floor
very
is
much.
yours.
Thank you very much. One question: do you see my slides?
Yes, we do.
Okay,
we
perfect.
have 20 slides, so we should go quite fast, I guess.
Okay. Well, I will go quickly through them. I mean, it has been quite a rich conference, and you heard a lot of content. So I will give you a quick update, and I will try not to go too much into details, because I think so far we saw many presentations, and I think some of us might be already tired. So I will be very clear in my messages. So well, thanks a lot for the organizers to invite me. So as said, I'm the executive director of EFRA. EFRA is an association here, a European association established here in Brussels, but truly European. And we have several roles. One of our main role is, in fact, to be the partner of the European Commission and of member states to implement the manufacturing related program in Horizon 2020 and in future in Horizon Europe. So we have already quite some experience and rich work done in the last 10 years between EFRA and the European Commission and member states in the Factories of the Future PPP, which started in FP7 and continued in Horizon 2020. And all these months and last year, we worked a lot to prepare the next manufacturing partnership in the next Horizon Europe program, and the partnership will be called Made in Europe. So there's a link, obviously, to Factories of the Future, but also there is progress and there will be some differences. So if I will first say some words on EFRA. EFRA is basically the manufacturing research community in Europe. It brings together all the actors, which are companies, research institutes, universities, and basically the main players at national and regional level for managers of Industry 4.0 smart manufacturing initiatives at national or regional level. This network is the perfect platform to cooperate. So not only on the European Framework Program, but also to cooperate in terms of bilateral cooperation between Germany and France, Germany and Italy, Spain, etc. So it's a kind of a meeting point also for managers of national platform to compare each other, what is happening, to do cooperation. And also in this context, Vanguard was already mentioned. So the regional dimension is very important in our work for several reasons. I mean, if you look at the European programs, they all come from somewhere. I mean, it's not that here in Brussels things are invented without a link to what's happening in the member states and in the region. So it comes out all from down, from regional and manufacturing initiatives. And then at European level, we bring all this together. So this cooperation with the national and regional level is very important. So it's important for the European level, but also for the national and regional level, because you compare the topics, the technologies, all these all this evolution of these technologies or other issues like standards, etc. Of course, needs to be discussed, and every nation and region has another view on this and another strength and another priorities in terms of industries, and then at European level this comes together. So this is what we try to kind of do at EFRA level to accompany all this work. Of course, we work a lot with events organized with the European Commission together or organized by us here. Just a couple of examples of events of a couple of last month. And if you want to think in the structure of the Horizon 2020 and Horizon Europe program, so we are in the Made in Europe will be located in the Pillar 2 in the digital industry and space cluster. And of course, I mean, I work EFRA and I'm presenting you the EFRA view, but as you know, the Commission holds the real power here in terms of funding, in terms of funding. So we help the European Commission basically to formulate the call topics in a way that it's industry friendly. And for this, we basically our main added value is this: we produce roadmaps and documents. So we organize public consultations, we organize a series of meetings and workshops where we let industry speak. What are your challenges today? And of course, these challenges evolved over the time. So we did this for FP7, we did it for in the beginning of Horizon 2020, we produced the FOF 2020 roadmap, then later the Factories 4.0 and beyond roadmap. And now the work of the last 1.5 years is to give for Horizon Europe the vision and the roadmap of what manufacturing companies are faced with at the moment. What are their challenges at the moment, and what are their opportunities? So here's a slide on factories of the future. This was produced by the European Commission, in fact, and you see here the importance of manufacturing. This was mentioned already before. How many jobs, how much of export it means. So 80% of Europe's exports are manufactured goods. So it's a highly important part of EU economy, which deserves a European support. And basically also this was the storyline of Factories of the Future. Such an important industry kind of needs a support. So if you now look at Made in Europe, you know, we identified what are the challenges, opportunities in today's business environment. And of course, the whole climate change debate is now more pressing and has higher importance than, let's say, 10 years ago. The technologies are different. All these presentations, these good presentations that we heard today are showing, especially on the digital side, what happened. And basically for manufacturers, this means all these new technologies, be it digital twin or digital platforms or others, they need to be integrated in the business. And of course, you have then the skills challenge. You have the competition angle. Everybody knows the Made in China program and other nations. They support a lot their industry. So we are in a competing world. So all this needs to be taken into account when we look at the next partnership on manufacturing. And also, so this was already presented partly by Matthias. This is the new commission, and of course, whatever is being done in Horizon Europe or Made in Europe needs to be in line with the policy of the European Union, set of course by the Commission President and the Vice President, and the two commissioners who are important for the Made in Europe program are of course Maria Gabriel and Thierry Breton, and everything what we do or propose and discuss is in this framework. And here you see the kind of the framework, the proposed framework of the Made in Europe partnership, the general objectives, and how they fit to general EU policies, be it on an industrial strategy for Europe, be it on the Green Deal or the digital agenda of Europe, and also an economy that works for people. So the attractiveness of the jobs question and the skills question. So in this context, the Made in Europe framework is written, and this is a kind of the overall framework. If you look at the left-hand side, the policies, how this relates to European policies. On the right-hand side, you see the technologies and the enablers that are available today. This was presented already before. And then you have here the Made in Europe for specific objectives. So all this you can also look it up in a document. I will just now show you the headlines, the pictures. So basically Made in Europe, this was agreed with the European Commission, and the member states will have 4 pillars. One is on excellent, responsive, and smart factories, where the competitiveness angle is in the center, so to be competitive at at worldwide level. The second angle is climate neutrality, circularity, circular products, and of course that's very important. And there, of course, the digital angle plays an important role. Here you have one picture explaining the 3 loops that needs to be taken into account, and beside the biological cycle and the technical cycle, of course, the whole information cycle, how to deal with the data, is very important. And data, of course, is here an enabler for progressing on the circularity path. Then we have so also in the past, we always need to look how production and the products that you want to produce, how this goes in hand. If the products change, be it that it's lighter, you're using more carbon materials, so this has an impact on the machinery, on the robots used. And so there is a whole priority looking at this, which is very important. And the last priority is human-centered and human-driven manufacturing innovation. It's the skills topics, but also how to deal with innovation management in the companies at all levels. So here you see on one slide the kind of the framework, the 4 specific objectives, and now at the moment we are doing, and we did a open consultation, and over summer and autumn we will draft the detailed roadmap for this, and this will then be the basis for the call topics that will be launched in the beginning of the program as of next year. So if you want to know more, you can check either the Commission's website. Here's the link, or the EFRA website. The document, the framework document, is there. As said, we are doing a public consultation to go more into details, to prepare the ground for the future call topics. And companies, initiatives, all these people, these experts who presented before me, partly already contributed and are invited here to contribute further to this work. Just go to the EFRA website, and it's a bottom up. So we listen to experts, to companies, to draft the roadmaps, which will then be the basis later for the call topics. So with this, I will close. If you have any question, please contact, of course, either the European Commission or EFRA. We are a very open organization, and as said, we have most players involved. The Made in Europe will be broader than Factories of the Future. Vanguard was already mentioned, but also other players. We will interact much more with anybody, with any organization which can provide an added value of bringing the research results closer to the market. So I'm also open to questions, of course, and I give back to Draško.
Thank you, Željko. Thanks a lot, really. Very informative. Okay, we do have a question here, actually 2 questions already.
Yeah.
I mean, the first one is to all speakers, in fact, those who are still here. So the question is, due to the COVID-19, some global supply chains were cut. Do you think the trend in the future will be to move the manufacturing back to Europe? That's a good one, because some companies are doing it already. I don't know how much is that in statistics, so to say, but it is a good question, I think. So anybody want to deal with this one?
I can react straight away since I'm now online, and then others can contribute. Of course, COVID-19, the current situation has a big impact on the discussion. It increased the need for a program like Made in Europe, and the program already says us that the aim is to produce everything what we need here in Europe. And I mean, it started with the medtech, medical devices, the masks and all this, but it goes beyond. So I think if you look at the EU policy over the last years, if you listen to the speeches of Thierry Breton, I think the sovereignty aspect increased a lot, because yeah, if you look at how China is acting, how Donald Trump changed the policy of the United States. So certainly there is a trend that there is a higher need for higher sovereignty. At the moment, we are a trading nation, if you want to call Europe a nation. So we cannot exaggerate either on the sovereignty path, because still there globalization is a fact, it's happening, and there are international value chains. And so we shouldn't abandon this. It's a competition at worldwide level. Those companies or nations who are better in something, yeah, it pays off, and this international trade will continue. But certainly on some strategic questions, we need to think very European, and we cannot depend too much on others. So already in the work of the Made in Europe document, the tone has changed over the month and years maybe, but COVID-19 certainly increased this trend.
If I may add, yes, sovereignty is high on the political agenda, but I think it's more important to talk about flexibility, because I think international value chains will stay important in terms not only of competition, but also co-opetition. You need these value chains, but you have to adapt quicker to changes, and here redundancy and resilience will have an increased importance. And for this, you need the data, real-time data. This I see as things that will change, but it won't be a complete back to Europe, even if from a political point of view, this would have some charm, of course.
Okay, thank you, Matthias. Anyone else? Maybe somebody else on this issue, or any other issue that we spoke today? Any other intervention? I mean, whatever we spoke today, or regarding some questions that were raised.
I mean, all I can say is I liked a lot the presentations before, and as I said, the regional and national level is very important. Of course, the European too, but I think every region and every nation needs to have its roadmap, strong players to see what for their region and nation is the competitive advantage, how this new technology needs to be integrated, and it's also a bit of competition, competition between these initiatives in Europe. So yeah, my message is we need to, at all levels, strong organizations. So when you in Slovenia, in Lithuania, or wherever, I think companies, universities, research institutes need to ask for regional, national initiatives and also strong European partnerships.
Sure. Yeah, by the way, the conference was also recorded, so we will put it on our website as well, together with the presentation. So I'm sure some of you will go into it again and maybe have some questions later on. So we are open for business all the time, so to say, even during the July and all the time really. So glad to help anyone. I think some people are already going offline. As it was a great morning, I'm wishing you a great afternoon with a perfect day with the event and the exchanges. Thank you for organizing a timely event. This is one of the opinions we got on the system in written. Really also on behalf of Slovenian Business Association and Lino, co-organizing the event, and of course DigiConnect, EIT Manufacturing, EFRA, so everyone included, and SRIP Top, so strategic cooperation for smart factories in Slovenia, the most active one. I wish you also the best day, and thanks for being with us, and of course thanks to all speakers being prepared to be with us and looking forward to further cooperation. I hope we will, this will be a fruitful one, and I mean the conference a fruitful one in order to maybe boost some more cooperation, some more synergy, some more projects maybe to go for. So that's the idea of such conferences, and thanks again to everyone.
Thank you for the invitation.
Thank you.
Thank you.
Thank you. Goodbye.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye.
Hope another time live.
That was within timeline, yes. Igor and Rudy, sure. No, I think good conference. I think I'm sure we will have some feedback. I mean, maybe not immediately through the questions, but maybe later on, because people do go on our website and look for presentations and so on. Igor and Rudy, yours was very good. I'm sure we'll have some backup. I mean, some feedback.
Okay.
Okay. we are in time schedule. Yes.
Drashko and Maya, thank you very much for invitation, for organization, and everything was really excellent, brilliant, and we hope another time we should continue with such a cooperation.
Whatever you want, we'll do it.
Definitely. Next time we hope it will be live.
Thank you, Drashko. It was really good.
Thank you.
Hope
Thank
to
you.
see you in person next time.
Yeah, exactly. We planned this one to be in live version, but
I know how it is. Yeah.
Okay, thanks for participating, Aleš. Hey, all the
No
best.
problem. My pleasure.
Yeah.
My pleasure.
Cheers. Bye-bye.
Cheers. Bye.
Bye-bye.